and welcome to, I guess, what is the next Into the Mix series. And today's conversation, I am personally very excited, not only for the guest that we have today and his level of experience, but also that we're going to be really looking at the problems that we all face working on film sets and really take a look at some of the optimization of our RF equipment and wireless workflow. And so often the answer is, well, check out this latest, greatest wireless system from this manufacturer. And this is all great stuff. And we're really seeing some great stuff. But today's stream is a little different because what we're going to be taking a look at is we're going to be really, well, first of all, debunking some of the common RF myths and mistakes, really, I feel that I know I've made on sets. And I think some of us are easy to make, and also talk about some of the solutions that we can put into place to make sure that we're really running what I'll call optimize RF solutions on a film set when it comes to our wireless microphones, when it comes to our IFB feeds, our comm sends. And there's so much happening right now. I mean, 2020, as we all know, has just been insane for all the reasons we all know about. And here we are. Some of us are getting back to work. Some of us are waiting to get back to work. July 13th flew by, which was the 600 megahertz turn-off date for wireless microphones in the U.S., with the exception of the guard bands at the low frequencies. And then there's talk of this Tband, 470 to 512 megahertz, being on the chopping block. And, most of us obviously are familiar with some of the common RF challenges on film sets. And, not only the obstacles from the basics of finding those clear frequencies that are clear of intermods, but also the antenna deployment, the type of antennas we're using, and hiding wireless transmitters on talent where the camera won't see, including the antennas. And with the goal of optimizing our systems. And we're also we're dealing with walkie radios on film sets. We're dealing with really helpful and cutting edge wireless lighting control systems. We're seeing more LED panels on sets. What else is going on? We've got high power video transmitters with our Teradex in the 5 gigahertz range. We've got focus pullers on Wi-Fi. And now mobile devices that are somehow operating in the 600 megahertz range as well, which is now off limits to us. So in addition to all of these challenges, we have to deploy quickly and efficiently. And for those of you who work in film and work in television often know that we are literally an hour to an hour and a half away from shooting when we land on set. All of these things have to be done quickly and efficiently. And we have IFB management. We have expanding microphones. I could go on and on all day. So gone are the days, really, I think, where we do a quick scan, throw up a couple LPDAs, put the transmitters on 100 milliwatt, and hope for the best. Because we're really in a new landscape. And so today's stream is really about growing our skill set and knowledge, and really in the 1 hour stream we're going to do today, it's impossible to cover all of the RF, training that we would need. So with our guest and what we're going to do today is we're also going to give you some resources where you can learn, study, and grow, because I think this is a craft I know for myself that I want to continue to learn about and make sure that the systems that I'm using on set are fully optimized and working really to the best. So we wouldn't be able to have this conversation without our guest, which I'm going to go ahead and introduce here. So let's put him up on the screen. There we go. And so today we have this very important conversation with senior RF applications engineer with RF Venue, Don Boomer. And he has worked in R&D in the past for Peavey, Sabine. I feel like I'm saying that wrong. I know that's the drum. Something with drum. In Line 6. And his rock band to sidetrack our whole conversation, just to have some fun for a second, from his school days, has a song in the Rock and Roll Hall of Fame. So, Don, how are you doing today?
Hey, it's Groundhog Day again, right? We're still still in quarantine and having fun in quarantine, I guess.
Yeah. Are you guys working remotely at RFNU or?
Yes.
Yeah, mostly.
Well, I pretty much always work remotely because I'm in California. Our lab is in Boston, so I've been remote for the last 3 years anyway. So
Yeah.
just fine with me.
Yeah. So not to embarrass you, but before we start and get into the conversation that we're supposed to have today, I've got a picture up of the album cover from your band, which, if I did my research correctly, I believe is called The Seeds.
That is it.
Now,
Yep.
you
That's my
guys,
my high school 15 minutes of fame. There you go.
you recently, not only did you have, well, a song in the Rock and Roll Hall of Fame, you also, one of your songs actually was recently synced, or you had a placement in Netflix Stranger Things.
Yeah, looks like they've gone out and found everything. Everybody's got a placement in Stranger Things, but
Yeah.
yeah, it song still gets picked up. It's been in a bunch of movies and a lot of television commercials, uh, and I don't get a dime from it. So we lost all the publishing and all that stuff.
Yeah.
We were dumb kids, and we didn't have lawyers, and we didn't have accountants, and we didn't care because in the 60s, we thought we were the end of the world, and
Yeah.
and didn't figure we'd make it to being 30 years old anyway. So who cared?
Yeah. Well,
But
just the fact that you had a song in the Rock and Roll Hall of Fame and a placement on Stranger Things, to me, is a really big deal. So I wanted to talk about that before we even got into it. And so Don, I had the pleasure and opportunity to watch and read through most of your blog content at RFNU, and your company and the company you work for as a senior RF applications engineer just has a wealth of content available, which I think is very palatable for a sound mixer to really, or sound engineer, whether if it's a front of house or no matter what kind of work, to really understand the fundamentals. So thank you for that. And it looks like that you're also one of the primary writers on the site. And recently, I think a lot of our minds, something that kind of was on my radar when I read the blog article about the 600 megahertz band turnoff finally being here, that you said that there's this possibility of this Tband being on the chopping block. Are we looking at another trimming down phase of the spectrum, possibly in the 470 to 512 in the future?
yeah, technically it's on the books. Technically it is a law, and technically there will be an auction next year. Right
Mm.
now, we don't think it's actually going to happen, but Congress will have to repeal that law. There is a recommendation from some congressional subcommittee to do that, but you know how those guys are. Whether they actually do it
Mm.
or not, whether it falls through the cracks. If it doesn't, I mean, if it falls through the cracks, it will happen. The idea is, that mobile carriers are willing to spend so much more money than television stations ever were, like 25 times more.
Hmm.
T-Mobile spent $8 billion for their chunk of it,
Wow.
and so some smart guys in Washington figured they were leaving $50 billion on the table. They might as well go get. And I mean, really, what they're talking about is shutting off over-the-air television, which almost nobody watches anyway. Everybody's got cable or satellite or something else. But that's where we operate wireless microphones mostly today. They did open up some new bands. There really isn't anything there worth talking about yet. Maybe some of you are using VHF, especially for comms. That's a really good idea. Get as much stuff out of the band that you can so you can find empty space. And then it's just a matter, really your only tool is to find empty space. And, if you can find empty space and move to it, you're good to go. If you can't do that, then you're in trouble. And empty space is getting more and more narrow. So That's where we are. That's why all of a sudden you're having to learn about RF that if you've been doing this for 20 years or more, you used to just turn on your mics and they used to just work. And now you have to do all the best practices that you can. I always talk about making wireless stay on the air is a straw that breaks the camel's back thing. It's usually not one straw or another, but it's too many straws and things start getting dicey. So if you learn a few little tricks, and that's what that blog's all about. If you go to our website, rfvenue.com, scroll all the way down to the bottom of the page, it's technical articles, but there's not a lot of math. I mean, if you really want to know, if you want calculators, there's plenty of college level papers with a lot of math that nobody can understand. Just guys that just want to do it. That's all for engineers. But if you want to understand, if I do this, does it get bigger or smaller? That kind of thing. So there's a lot of stuff. They're short, they're 5-paragraph articles. Take you 5 minutes to read one. There are literally several hundred of them. But if you scroll through that real quick, you probably know most of them, but there's maybe one or two that'll surprise you that you didn't know about. And it's like, oh, if I did that, that would help. So that's why they're there.
Yeah. Another mixer friend of mine in the community, early in January, February, we're doing a lot of research and learning from your site. And I loved you guys also recently in March when this whole thing happened, you launched like a webinar RF training series as well.
Yeah, if you want to go into it a little more in depth, I think there's half a dozen articles. They're about an hour long, depending or not whether we left the questions at the end of them. But while you're currently unemployed, waiting for something to happen, and you got some spare time, if you want to watch those, it probably makes it more clear to see it, demonstrated than to just read it. But it's all there too.
Yeah, and kind of what we have outlined today with Don is really thinking about some of the common challenges and a lot of the questions directly related from those training series and blogs. So be sure to, if you want to dig in deeper or do more research, which I highly suggest for all of us, you can do so there. So Don, speaking of blogs and conversations and things, in your article, Why Wireless Mics Drop Out, you spoke about 3 primary reasons why wireless mics drop out, which were range being one, multipath reflections, and cross-polarization. So what particularly caught my attention in this webinar, and I believe it was in this webinar, is when you mention a common mistake is a user will attempt to increase the transmitter power to solve RF signal or a dropout issue, which actually can work against you when using multiple transmitters in close proximity, which is what we do. Can you expand on that, please?
Yeah, it seems counterintuitive. I think most people came to this business from the audio side. They know about recording, they know about amplifiers, they know about speakers, they know about microphones. And wireless is just a tool. We just replaced a wire. We're not very exciting. But with radios, every radio that's on in the world right now is interfering with every other radio that's on in the world right now. I mean, radios that are on in China right now are interfering with whatever we're doing right now. It's very small because it's so far away. So what you're trying to do is keep the power down. And maybe an easy way to think about it is like with digital recording. It used to be with VU meters, you could go over and maybe it gets a little distorted, a little grainy or something. But with digital, when you get past 100%, it's just terrible, right? So the same thing kind of happens with radios. You want to be, actually when you're setting up your radios, you're looking at your meters. Where you want to be is about 80%, because inevitably somebody's going to move and get a little stronger. They're going to get closer to an antenna. You just never want to go over 100. And so what you're shooting for is the lowest power that works. That's got to work. But if you can cut your power in half and it still works, you will have a lot less interference between units, a lot less intermod between units, a lot more open space to set channels. If you power up, the ENG guys using 250 milliwatt transmitters, and when one of those guys comes on the scene next to you, you may lose a whole bunch of channels because it just screws it up for everybody. So we always want to look at the smallest amount of power that we can. In fact, and this will sound really counterintuitive, but if you're using analog wireless and you can actually pad down with an inline pad, your antenna signal, you'll actually improve the sensitivity of your receivers.
Wow.
So I know that sounds funny. It sounds like,
Mm-hmm.
gee, if I want to drive my car down the street, if I threw an anchor and dragged it, that's what this sounds like instead of just taking my foot off the gas. But if you pad the signal coming in, you lower the noise and the signal. And really, the thing that always gates us is our noise floor. Whatever that is, that's what we're stuck with, and that's other radios in the area, that's cosmic waves from outer space, that's everything, sunspots, that's there. You can't do anything about that. What we have to do is get our signals above that. But if we put a pad and we drop that, then if we put a 10 dB pad, we drop the noise floor 10 dB. We drop the signal 10 dB, but that's easier to deal with. The noise floor is not really something. There's not a box you can twist the knob and change your noise floor.
And Don, just so I'm understanding, if so, let's say you've got 5 to 7 wireless on a set, and you're doing a scene, and one of the wireless is, let's say, inside of a vehicle, and the signal is maybe not doing as well as another transmitter that's in the vehicle or the ones that are on actors' bodies in the scene. Is by increasing the power to the transmitter in question that maybe you're not getting it enough of, does that physically raise the RF noise floor?
Yes. Yeah, because all right, so when we talk about a radio frequency, a radio channel, it's not a single frequency. It's the tip of a pyramid, right? Mm-hmm. So the way I usually explain it is, if we're sitting, having coffee, and we're socially distanced 6 feet apart, and we're speaking to each other in our speaking voices, everything's fine. There's our power levels. But if I get up and I put my mouth a quarter of an inch away from your ear and speak at that same level, you would now say I was screaming at you. The power didn't go up, but the power got closer. So in the case of your car, remember I said the lowest power that works. So it's got to work, and if it's a metal car, you're obviously blocking a lot of signal getting out. So in that case, you would both boost the power of the transmitter inside the car, but since it's not going to get out, you're just trying to get it up to a level, and since most of it's going to get blocked, then you don't have to worry about that. So let's see, I have to shut something off on my computer here. Okay, there we go. So like I said, it's the power that matters. So if that power doesn't get out, yes, it's strong inside the car, but to an actor standing outside the car, it's not as strong as if it were. Now, if the guy's getting out of the car, as that's part of your shot, then you have to deal with that. It's going to change. Is it going to wipe you out? I don't know. That's going to depend on a bunch of other things. And it's always, again, because of the proximity thing, like me up to your ear. Yeah. When you get people close together that have transmitters, if you have two people that have to hug in a scene, that's going to be the very worst time for your transmitters, as opposed to if they move 10 feet apart, that's going to be the best time. And since it's always moving, there you are, So
yeah, and I'm as guilty as anyone thinking in terms of frequencies and avoiding intermods, and like that's the game. And then from there, when RF signal looks low, increasing power. And it's really interesting to me how you talk about all of the input in the overall system, how the noise floor, because really we're going to talk about carrier to noise ratio a little bit here further on, so everyone has an understanding of that, is how really this power variable really comes into play just as much as frequency coordination and avoiding intermods. And I can't count the number of times you had talked about someone coming on a film set who's maybe doing a behind the scenes EPK or interview, which is common in our world, maybe not so common coming up here soon, but, telling, okay, well, they'll come to, hey, don't fire up any transmitters until you talk to us and we'll give you some clear frequencies, which is common protocol. But I rarely have asked the question, or never is probably a more honest answer, what are your transmitter power levels? And if they are, we have a lot of electrosonic, Zaxcom, audio limited, and different types, of common type receiver transmitters for talent on set. And these transmitters can output quite a lot of power. Some of them all the way up to a quarter watt.
Yeah, and of course you have to have a license to transmit at quarter watt and
a Part 74 license.
A Part 74 license,
which I have.
Yes, yes. Oh, you do?
Yeah. Oh, absolutely, I do. Yeah.
Yeah.
Most I think production mixers working on larger scale film sets do have the Part 74 license because we're running. Sometimes. I mean, what's the limit on power for non-Part 74 users, Don?
50 milliwatts.
Okay, 50 milliwatt. Yeah, so I'm most commonly running at 100 milliwatt, but have found myself, I've done a couple gigs recently going down to 50 milliwatt and really thinking about this power thing a lot more from the learning and so far I've been doing from your webinar and training. So yeah, thank you for that. That's a great, just really valuable information. So next question, really, most of us working in the field of professional audio have learned early on about the importance of optimizing signal to noise ratio with microphones and preamps and gain staging and how a system works, all the way through a full audio system like a proper sound card or bag-based system or however you're working. And I heard you speak often about CNR, carrier to noise ratio. Explain how this relates to signal to noise ratio, which most audio folks I would assume are familiar with, and how we can optimize this on an RF system in the field on a film set.
Yeah. So actually, it is signal to noise ratio. It's just that, we develop fancy jargon, I guess, so we can charge more money for stuff. The carrier is the signal.
Yeah.
And so that's what we're talking about. Basically, the sort of rule of thumb is that your carrier needs to be at least 20 dB above your noise floor as a minimum. I would get, I mean, it could work at 12, it could work at 10, but boy, I'd be very frightened. If somebody turned sideways and it would stop. So at 20 as an absolute minimum, most of the time it's much higher than that. Most of the time, you guys are fairly close to what's happening. I mean, if you're trying to get somebody that's on the other side of a football field, well, maybe not, but you guys are usually closer. Most people are using wireless mics at 20 feet, right? 50 feet. It's fairly rare, and you can think about your own experiences, but I'm going to guess that most of them are pretty close up.
Probably a lot of, usually the edge of set, I think, is pretty protocol, and I would say, 100 feet max typically is about, Yeah.
See, that's the thing. Again, that's why you don't, you don't want extra power, because you're not really trying to go a long distance. I had I was doing a training at Location Sound Burbank. Maybe some of you guys go there, and this guy came up to me afterwards, and he was just all upset because he just bought a whole bunch of Electro, $3,000 a piece wireless mics, and he said, "Are they lying to me? They told me these would go 300 feet." And he said, "I have them drop out at 20 and 30 feet. Did they cheat me?" And I went, "No, it's interference. Because if we go stand out in the middle of a cornfield in Indiana, your wireless mic will do a quarter of a mile maybe. Yeah. But you bring that same thing to downtown Atlanta or downtown Burbank or downtown Manhattan, and you might not get 20 feet because there's so much interference competing with you. In other words, the noise floor is so high. And we have some new things now that we didn't used to have. We have those T-Mobile pink lightning bolts, which are just turning on. We see a lot of commercials on TV And frankly, that service has been on in a lot of the country for 3 years, but nobody had a cell phone that worked on it. There were very few. iPhone 11 works on that. It's called Band 71 in T-Mobile world. Works on that. So, there's how many millions and millions of iPhone 11s out there. They're still doing 4G.
Yeah.
When iPhone 12 comes out and they start actually transmitting on 5G, the data rate is so much higher. There will be, even if there's the same number of cell phones in your area, they'll be broadcasting 20 times as much data. So it will feel like 20 times more people. And even though they're higher in frequency than you are, because the lowest frequency T-Mobile can transmit at is 617 megahertz. And theoretically, for most people, the highest you can work at is 608. There's some exceptions, but let's just keep it there for now. But they're transmitting in a very wide band.
Yeah,
it's sort of a spread spectrum-ish kind of thing. And when they're up there, they're creating intermod with you down to about 550. It just looks like your noise floor just gets elevated.
And is that across the full frequency range? Like, are we seeing the noise floor also increase down to 470? And when I say the full frequency, I mean for where we use wireless microphones.
Down at the bottom, there's some new things. Most of the new things are LED lighting.
Okay.
So LED lighting spits out garbage. And then, of course, you got your walkies, which most of those, they always rent Motorola units and they're always on channel 1, but they can transmit up to about 460. So they're not too far below you. And again, if they get close, if some guy with a radio keys his radio and he's standing next to your antenna, he's screaming in your ear, and that could wipe you out. So
and we're going to talk about a couple tools in specific that we learned on. I learned about later on to help lower that noise floor. But when you talk about we need 20 dB difference between the signal to noise to have a usable wireless microphone, there's also limited headroom there as well. Is that correct, Don?
Well, yeah. I mean, if you actually want to know what you've got, what we do is something called a link budget. And you can Google link budget calculators. There's very simple ones. There's very complicated ones. But basically what we do is we add up all the pluses in your system and we subtract all the minuses, right?
Yeah.
So if we're talking about a wireless microphone, their output is plus 15, and then you're going to transmit 50 feet through the air, so you're going to lose 56 dB.
Yeah.
Now you're down in the 40s, and then you're going to lose some in your cables, and you may gain a little bit back in your distro, and so you're going to come out with a number at the end.
And just to clarify for everyone, so the milliwatt transmission of your transmitter can be directly correlated to the dB output level. Is that correct, Don?
Yeah, right.
On the link, but because I watched that on the link budget, and it's also an online app that I'll put a link below that it's on. What's the name of the gentleman who created this software that everyone could use, Don?
Well, the really intense one. There's a fella in Nashville named Jason Glass. Okay. And this is the guy you go to when you want to do the Olympics or you want to do the Democratic National Convention. Well, assuming they had one, where you want to use 200 microphones or you want to do the Super Bowl, you hire a guy like this. And his calls out, every quarter of a decibel. He wants to know whether your BNC connectors are brand new, sort of new, not new. I mean, he's really got it down. I don't want to be that close. If I'm only a dB and a half away, I'm scared. I want to know that I'm 10 dB away. Then I can go work. So his has everything, every brand of cable, every brand of microphone. It's very, very detailed. I mean, if I got down to then there's very simple ones that only ask you about 6 questions, and that's easy. And their margin, their give or take, 3 or 4 or 5 dB. Like I said, I want to be way better than that. If I know I'm way better than that, I'm not going to worry. If it's looking pretty close, then I'm going to have to really start thinking about everything.
Yeah.
And there's one thing I'd like to add before I forget.
Sure.
Your coax cables that you're winding up every day, those are expendables. You need to throw those away every year or two. Unfortunately, it takes a very expensive $8,000 device to measure them. But what makes a coax cable work is the fact that it's perfectly round. And as people step on them, as you kink them to go around corners, or you get them caught in the lid of a trunk and you kink it or something like that, every place that cable's not perfectly round, you get an echo in the wire. Is the easiest way to explain it. So just like trying to have your microphone work in a basketball gym where it's all echoey, the same thing happens to your radio signal. So in many ways, your coax cables are like the tires on your car. Every time you go around the block, you have worn a little bit of tread off that. Now it's a long time until your tires get bald, and it's your choice when to replace your tire. Gee, that looks bald to me, might not look bald to somebody else. But you're starting out with that cable being 99.9% good, and every time you use it, it's getting less and less. Is it 60%? I don't know. You can't tell to look at it. It can look really good, and without a VNA checker or something, it's very difficult. People try to check them with a multimeter.
Yeah,
that's going to tell you that it works at DC. But we need it to work at 550 megahertz. And so it's a whole different way you have to look at it. So if you're using cables that are a few years old that have been wound up a bunch of times, or somebody drove a forklift over, or a hand truck, or even stepped on it a number of times, it degraded some. I can't tell you how much. And again, back to that link budget, maybe you could suffer a 20% loss in your cable and you're still good to go.
Yeah.
But the next time you use that same cable, the venue might be different, and you don't have that headroom anymore, and now it's causing you grief. So,
is that the symptom? So if you're dealing with a 50 ohm coax cable, and you think it's good, but it's actually got some of this mirroring problems that you're talking about, like what happens? Is it decreased RF signal strength? How does it affect the system?
What happens when you have an antenna and you have a cable and you have a receiver at the other end? Mm-hmm. What happens is, so the signal's coming into your antenna, and you think it's going through the cable to your receiver, but part of it's bouncing back. The same thing happens with speaker cables and speakers. It's called back EMF. Okay. But the same thing happens. It keeps getting harder and harder to push down that cable. It's pushing back at you, and when as it pushes back, you're simply losing power through the cable. It's pretty simple. It's coming back as echoes, but you're not getting all the power down through it that you think you are.
And it's interesting because I've heard obviously about that before, like, oh, you got to, check your coax cable if it's damaged or in any way, but it could just take a kink because, for those, just to bring up again, I think you guys had like a 30 or 45-minute video just on coax cables. And it was, and I thought to myself, I have to buy all new coax cable. I mean, I've been using the same LMR 240 for 2.5 years. And everything that you've spoke about getting run over, all of that happened to it. And it's, and I think we're all guilty. I think a lot of us, of doing, continuity checks with a multimeter and saying, okay, this cable's good. It's functioning. It, like you say, it's only, but I'm going to put a link below, guys, a name of this machine that can check cable. Cause I'm hoping one of our usual suspects, and I mean vendors, our True Audio, Gotham Sound, Pro Sound in New York, or just has this. Cause I mean, if I have $1,000 or $1,500 worth of coax cable, because I'm buying the nice stuff, like you had talked about 100% shielding versus 95% and some of the difference between those. It would be nice to be able to check those cables for wellness rather than just saying, hey, every 4 to 6 months, because a TV show is all it would take. for those cables, I mean, unless through a miracle, they never get touched.
Yeah.
So
The problem is, even if they measure it for you,
yes.
and if they tell you your cable's 85%, you've lost 15%.
Okay.
That might work great 99 times out of 100.
Okay.
And then that 100 time that doesn't work, or it might work 10 times out of 100. It just depends where you are. So,
yeah.
So if I give you a number, I don't know what that means. It
Sure.
means I have to put that back in the link budget for the exact space you are. And I don't think anybody's going to work that hard. It's different. I have microphone cables that are 40 years old that are still working at 99%. They pretty much work until they die. But it's always a diminished return on coax cables.
What's the name of the piece of equipment that will check the wellness of a coax cable again? What is it called, Don?
Well, we use a thing called a VNA checker.
Okay.
VNA.
VNA.
Yeah,
okay.
you can do it with a spectrum analyzer and and an RF generator as well.
Okay.
Now that there are inexpensive spectrum analyzers, we make a little one that's $500. I mean, before that, the last one I bought was $18,000 and it weighed 80 pounds. Now it's $500 and you put it in your pocket. So people can actually afford those things. They'll give you a reasonably close measurement. I mean, maybe they can't tell the difference between 83 and 88.
Yeah.
Where a really good one could tell you 85, but at least you're gonna know you're not at 50%. That kind of thing.
Yeah.
So you could do that yourself, and I would suspect that maybe some of those dealers could do that for you. I don't know, but I'm just saying, just be aware of it. First of all, inspect your cables. Anything that's got a gash in it, or I'd just get rid of. Cables are reasonably inexpensive, and having a bad day on set is not. So you want to take care of the little things.
So Don, let's talk a little bit about something that you guys specialize in, specifically in your product range, which is antennas. And I've got a couple different questions surrounding antennas. I think that would be useful. And speaking of the conversation that we had about increasing gain as being a misconception to increasing performance, which I think most everyone here has a handle on, tell me about the benefits of using low gain antennas. In particular, your RF spotlight antenna, which we're starting to see some on film sets now, which I believe has a -1 dBm gain, which I could be wrong about that spec, but I know it's a very low gain antenna.
Right.
And I read, and this was a while back, I read an article on your site, and this was early this year, where you guys had set up a stage performance in Central Park. And the RF was impossible. And you even had mentioned another venue that you worked with this antenna where it was the same thing. They were doing remote interviews. It was just, you look at the RF scan and you're just sweating bullets. There's nothing available. Tell me about this antenna, and is this something that could help us lower the noise floor in a very busy environment? And help us get usable frequencies?
Yeah, I've got a little video here that runs 1.5 minutes that I can show you, and actually gets live. So
let's do it.
Okay, let's see here. So I'm going to share my screen, and I'm going to play this, I hope.
Yep. So we're not seeing the screen yet, Don.
Well, let's see. It's full on mine. What did I not hear? The share? Are you getting my screen now?
Not yet.
Oh, start sharing. That button. Okay, now you should have me, right?
Yes. I see me. Let me add it here.
Okay.
Oh, it's locked. Hold on, let me fix it. There it is. I see myself.
See yourself. Do you see my screen?
Yes, sir. We see your screen.
Okay, let's try this again here. Let's see. Come on. All right, let's. You see my beautiful face there?
I love it.
Okay, we can do this.
It kind of
Here we
reminds
go.
me of Back to the Future a little bit. The DeLorean is right off screen.
There you go.
No audio,
No
Don.
audio. Okay. So this is at a convention. We're seeing lots of uncoordinated microphones. There's maybe 200 microphones on at the Las Vegas Convention Center. And yeah, it would be typical. If you're outdoors in a big city, you've got stuff
Mm-hmm.
like this.
Mm-hmm.
So what we had that little rubber antenna. It looks like a rubber pizza. We're trading distance for attenuation. So I'm going to switch it to that antenna, and you can see everything drops out right there, and there are my microphones, the two tall ones. But I've dropped everything else around this quite a bit.
Holy
Uh,
moly.
so if I had to quick turn on 10 more channels, I've got a lot more space where I had like none before that. It would have been really difficult. But by switching to this antenna, which won't go very far,
Mm-hmm.
I do that. And then if that's not enough, I've got
Yeah.
these bandpass filters, which is that little block. And if you put that in, then I can block out things that are out of band. So you can see I dropped the picking up external stuff a whole bunch, right? Yeah, you can
So
see
so that's the spotlight combined
with the bandpass
with the
filters. Yeah,
bandpass at the Las Vegas Convention Center.
yeah. Oh, that's a flattering photo. Yeah, if you look at the two,
Yeah.
looks like about 545 and 560. Those are the two wireless mics that are there on my table. So that's all I care about. I would like nothing else to be on the screen except those two mics. But you can see I don't have a lot of competition at this point.
How much
So
dB do you think you gained in signal to noise performance in the frequencies that you're using, Don, by using the bandpass filter and the spotlight antenna?
oh, right there, 15 or 20.
That's incredible.
10 to 25 times less noise.
Wow.
Which, like I said, it's really easy to get the gain. I could turn those transmitters up if I needed them to be higher. That I
Yeah.
can do. But just having a dial where I turn down the noise floor. So what I've got here is an antenna system that simply ignores that noise floor.
Yeah. So
And,
so so another question about antennas. I hope you have a lot of those in stock right now. Because just a quick question. When we think of antenna arrays, especially, it's not an array because it's actually when we think of antenna diversity pairs.
Mhm.
Should we, when deploying an antenna like this, should we be thinking in terms of diversity, or
You
can it be
still
combined with another? Like what? Or should it be
no,
two of them? Like what do you think?
you need two. Most cases you need two
Okay.
because if you switched over to the B antenna
Uh
that
huh.
was a regular antenna, you'd be back to all that noise. You'd be wiped out on it. So
Yeah.
you would have in effect probably not have any diversity. I'll tell you where the guys don't do that. If you're doing my cousin worked on one of those uh, scandal entertainment shows.
Mhm.
Which one? Anyway, I mean, he basically went to the hotel every day, and they did an interview with a movie star promoting their new film, and they bring in all the other people. Everybody gets their 5 minutes with them, and they're
Yeah.
sitting in two chairs, with a table with a potted plant on it or something, talking about the new movie. Extra, it was called, and he has just used one because he literally was 5 feet from the person. Nothing was going to change. I mean, at that point, straight power was going to win. So you could just put one under the table. They're pretty easy to hide. They're, the size of a pizza, and they're a quarter of an inch thick, and you can walk on it. I mean, you can't drive a forklift on it, but I think
Okay.
we rate them for 400 pounds or something. So
Wow.
they're pretty good. And it's just that kind of thing you should have in your toolbox
Yeah.
for the day that the thing that you want to use doesn't work.
That's right.
But like I said, you're limited. This antenna simply can only see about 50 feet, and then it sort of hits a brick wall.
Yeah. That's
So
good to know. So about a 50-foot
yeah,
diameter.
yeah.
And
So
and I don't usually go to questions this early, but it's a good question, and I think it's a simple answer. Alari Civil says, as far as reducing the noise floor, which is obviously the goal to increase the carrier to noise ratio, could this be achieved with attenuating a more sensitive antenna? Meaning, can you use this passive bandpass filter and still decrease the noise floor with a more high gain sensitive antenna?
Oh yeah, yeah.
Okay.
You can add those.
Yes.
So the one thing that those bandpass filters will do right away
Yeah.
is they'll block out T-Mobile.
Okay.
Do you know, I can tell you these will be absolutely necessary in your system in the future, but I can't tell you if that future is next week or next year or the year after that.
Now, some of the systems done, and I don't want to talk about specific brands or types or whatever, but have filtering built into the racks, or we're seeing some antenna systems, some cutting edge antenna systems that have it built in. Is there a benefit to this, just a singular filter versus one that's built in to the rack, or are they the same? Or
no, the ones that are built in are very mild filters. They're probably 6 dB per octave, or what we call first order filters.
Okay.
Ours is the 6th order filter, and will literally knock down 40 to 70 dB right outside its cutoff frequency.
Okay, and I just thought that because if someone already has something like that, like a lot of us do, it's even better if we have one of these filters like these. I call them analog filters. Is that even the right word?
Yeah, they are.
Okay, analog filters in line with that. Should we be using it with our existing filters, or does it just?
Yes, you can stack them up. You can stack them up in series.
Okay.
The problem is that all the stuff that's built into everything are electrical filters, okay? And they happen after the RF that comes into your antenna gets converted, right? It's already hit your system. You have to block it before it gets to your system because it can wipe out your first stage. And so the internal ones are usually built inside the second stage, and they do help, but not nearly as much. I mean, you're going to cut it down another 10 dB from whatever that filter is already giving you.
That's good. That's good to know because in some of the different, I have a couple sound cards and different systems, and just saying, well, I've already got these built-in filters for specific scenarios, and I wondered if there is a benefit. It kind of reminds me in music, Don. You being a musician of the real analog gear versus the plugins. It's like the real stuff always sounds better, it just does. And okay, so one other question that I had that I'm really excited to get the answer from is so a lot of us on the sound cards we use varied types of antennas. I mean, quarter wave whip, diversities, for those doing bag work. LPDAs are very common in a diversity pair. Then we also have dipole antennas as well, and then some helical designs as well. And I've seen users mismatch these things. I don't want to necessarily want to go into mismatching as much as I want to talk about. We're usually 100 to 150 feet from talent max, sometimes closer. On the edge of set is the way to think about it. But in reading through your tech article, something that really caught my attention was polarization. And it got me thinking a lot about how we hide transmitters on, because in narrative work, a lot of it is like, where can we put it that it can't be seen? I mean, some of these wardrobes can be so minimal or just challenging in a way that we have to find. It's very common. And I loved your tip about putting straws around antennas. We can talk about that if they come in contact with body. I've done that some on set with boom ops where they're using packs that sometimes if the antenna gets hit, it goes like, you get this little kind of, it sounds like a slap delay or something. But anyway, the question is this. So is really LPDAs beam width versus helical, is a helical diversity pair beam width comparable enough with an LPDA to be on par with performance? And the helical has a spiral polarization pattern
Right.
versus the linear polarization pattern of the LPDAs or the dipoles. Is it a benefit to use a spiral type pattern on a film set because of the varied antenna placements over an LPDA? Or is it possible that the beam width and gain is too hot and could cause problems?
Well, the answer is both things could happen. So gain of an antenna is not like gain with an amplifier. Gain of an antenna is just focus, right?
Yeah.
So if I use a whip, it picks up in 360 degrees.
Mm-hmm.
If I use an LPDA, it picks up in about 120.
Okay.
So we take that other power and shove it into that smaller section, which makes it look like it stretches out further. But it's not really amplified. It's just when you do this, when you yell at somebody, or when you do this up to your ear to hear, you're trying to focus that sound. So it's a focusing kind of gain. Helicals can be really good in avoiding interference. So if you use a whip antenna, then and your talent's out in front of you, it's picking that up, but it's picking up everything behind you too. So if there's something noisy behind you, RF wise, that's getting into your system. If I swap that whip for an LPDA or a helical antenna, then what's behind me doesn't matter because I can't see it. I can't hear it anymore. So in that sense, there could be a lot to be gained with that. Helical antennas are even much narrower. So helicals are generally about 60 degrees. LPDAs are generally about 120.
Okay.
So a helical has half the width.
About half. Okay.
So if you had, for example, if there was something on your stage that was causing it, if you're shooting somebody and they've got a generator going there, or something with a motor, or something with a big computer, and it's actually working, it's spitting out a bunch of junk. You might be able to narrow in with a helical, but you're probably not going to be terribly successful at that. But definitely from behind you. So if you know if you're working in a city and you know where your television is being transmitted from, if you can put the backside of your LPDA and point that towards your television stations, and then point the front side towards your talent, you will have less interference from all that TV, and that'll lower your noise floor a little. Now, that's not always possible. In fact, sometimes you're going to have to point them right at it because that's what you got to do.
So because you're avoiding camera so much, it's about not being seen and not being in the way as well.
But if you have the opportunity to do that, and you know to do it, it could benefit you. But polarization. Everybody knows what Polaroid sunglasses are like, right? You take the glasses and you go like this, and all the glare goes away, right? So antennas have a pickup angle, and much like microphones do, right? You point a shotgun at something, that's what you get, and you ignore everything else. Antennas. So actually, I've got a little slide here I can show you.
Yeah, great.
All right, so we're gonna struggle through this again. Share screen, and we're gonna see if this works. You got that?
I do. Yeah.
Okay. All right. So if if my antennas are, and these could be LPDAs or whips or anything. Okay. So they're straight up and down. They're going from 12 o'clock to 6 o'clock. And I'm showing this with a stick microphone, but it's the same thing for a belt pack. Okay, so if that microphone's going straight up and down from 12 o'clock to 6 o'clock, and my antennas are straight up and down from 12 o'clock to 6 o'clock, that makes the antennas the most sensitive to that transmitter they can possibly be. In other words, they will accept all the power that's coming from that transmitter to them and not lose anything. The problem is when I twist. So now if I pick that microphone up at a 45-degree angle, I lose 3 dB. I lose half the power in each of so this is my diversity channels, A and B. I lose half the power, which still should keep you on the air. But here's the killer. If I turn that mic 90 degrees, I lose more than 20 dB in each side. I'm at less than 1/100th of the power. So realize people are always moving. You're now non-polarized. This would be called polarization crossfade.
Mm-hmm.
So we make this antenna, maybe some of you guys are using this, called a diversity fin.
Mm-hmm.
And this antenna switches. So when you have two LPDAs, they're switching back and forth based on the power that each one gets. The
Okay.
strongest signal will go into your receiver. This one switches between A and B based on the quality of the signal, not the strength.
Yeah.
Now, most times the strength is the quality. 8 out of 10 times the strength is the quality, 9 out of 10 times.
Yeah.
But sometimes it isn't, especially if you're using digital receivers. Because now digital, what we're talking about is bit error rate, right? So when we get too many bit errors in that stream of data, we drop out. So here's what happens with our antenna, because
Yep.
it switches on polarity. It already starts off with one channel dead, but one channel perfect, right? And as I turn to 45, I lose 3 dB in both channels like I always did. But if I go all the way completely out of polarization, I lose one channel, but the other channel becomes 100%.
Yeah.
So the worst I can ever do is lose 3 dB, but so I'm 0 on one antenna and 100% on the other antenna. I'm never 0 on two antennas with this kind of a system.
Yeah. And
So,
those are significant losses and
yeah.
gains.
Oh, that'll wipe you
It's
out.
not, yeah. And so to the question of is the polarization pattern of the helical, I understand the beam width and you get the 60 and 100 degree,
Right.
but is the polarization pickup pattern of the helical more ideal for random transmitter placements with quarter wave whip antennas that could be all kinds of different directions on actors?
Well, so with the helical antenna, because it's spinning,
Mm-hmm.
it's always at -3.
Okay.
But it's never any better and never any worse. It's always at -3. So, once you get it dialed in, it's going to stay the same.
Okay.
If I had a situation where I was shooting somebody and they were on the 1 yard line, and then and in one shot they were going to run all the way down to the other end of the field,
Yeah.
I would use a helical for that,
Okay.
because that's gonna, I don't care. Up close, the way more normal kind of things are, I guess that's normal. I would use that diversity fin.
Yeah.
It just has the smarts built in the antenna, so you don't have to do anything with it. Plus, it does connect with two coax cables. It is two antennas. It is A and B, but you've only got to put one up on a stand, so it'll save you 2 minutes in your setup. You don't have to run a cable to that side of the set and that side of the set and put up two mic stands with the antennas on it. You only have to do one.
Yeah.
But it can't get moved. It can't get bumped. I'm sure that's happened to you guys. You get everything set up and you take a break and you come back and all of a sudden it's not working because housekeeping cleaned and they lifted your antenna up and they thought they put it back in the same place and they didn't. I mean, that's happened to me. So
house cleaning moved the antennas.
Yeah. This was a live show.
Okay.
Yeah. And so we did sound check. Everything was set up. We did a dinner break. We came back.
Yeah.
And housekeeping had vacuumed the stage. So.
Yeah.
And there's all kinds of things. I mean, you guys have a million things. Stage is just a stage. It's always pretty much going to be the same thing. Housekeeping may be putting dirt in your scene. Who knows?
Yeah.
You got everything.
Don, talk about it, because I don't feel like the two final things I want to talk about with you, because and guys, keep in mind that we are literally touching on topics that RFNU has spent the time and energy to do detailed streams, the length of this stream on just one specific topic. So I encourage all of you who are to research and watch these series, because I know for myself it has been incredibly beneficial, and also to ask these questions has been so great, Don, and thank you. What we didn't talk about is two things, and they're not so sure how much they are related, but multipath reflections I want to talk about a little bit, and some of the common pitfalls with multipath and things we need to be thinking about avoiding. And the other thing is the benefits, going back to the power conversation, and increasing and decreasing the noise floor with bandpass filters. want to talk about the benefit. Well, first let's just talk about the first part of that conversation, which is multipath, and then I'll do the next one.
So multipath is reflections, and to a radio, it's like old analog TV when you used to get ghosts. Radio bounces off everything metal. So anytime there's anything metal, your signal's going out all over the place. So you're getting usually hundreds of reflections into your antenna. So at any given instant, any given syllable is arriving at your antenna out of time 100 different times. And your receiver has to figure out which one it's supposed to listen to. Now, receivers are pretty good at that, and they'll handle that, but it gets to a point where they can't. So you have to be aware of metal. If you have an actor that's going to walk along the side of a building, and they're going to walk past an aluminum garage door, all of a sudden everything's going to go wanky when they walk past that, right? Because now they're up against a big piece of metal. Broadway guys have big set pieces that have metal frames, and as people walk by those, for the 5 seconds they're walking by it, all kinds of hell breaks loose. There's really not a lot you can do about multipath reception. You don't ever want to set your antennas up very close to a wall. Leave about 6 feet from any kind of a wall, especially a metal wall. Live shows, I get guys that want to mount antennas on lighting truss because it's easy, but lighting truss is a horrible reflector, so don't do that. There's probably not much you can do about multipath. It's all these things together, right? So you just kind of have to be aware of it.
And you had also spoken about in your webinar training series about there was like a curve, like 3 specific curves in which an antenna path travels. Is that ringing a bell?
The signal from an antenna has what they call a Fresnel zone.
That's it, the Fresnel zone.
So when it comes out from an antenna, it's actually it's actually like a hot dog. No, it's more like a football.
Do you have a screenshot of that, Don? Not to put you on the spot, but there was a very specific screen grab you guys were using because it was really relevant to the height of the antenna as far as how close the antenna was to the ceiling. That really majorly affected the performance of it.
Yeah, the bounce off the floor and the bounce off the ceiling, if they're close, come in out of phase, whether that's metal or not. So that's just more multipath. I don't have that shot.
Yeah, and go ahead. I didn't mean to interrupt when you were explaining
it. It's basically, so your radio is not transmitting like a lightning bolt. It's transmitting like a football. And so, it's a point at one end and a point at the other end, and then it goes above and below. So those above and below bounces are what cause multipath.
Okay.
So
sometimes by lowering or raising the antenna.
Right.
And it's not just thinking about, because I think a common misconception is it's about obstructions. It's about what's in front of the antenna.
Yeah, you'd like clean line of sight.
But too high to achieve that can create multipath, correct?
If you're high up against the ceiling, yes. Okay. And if you're low against the deck, you're in trouble.
Yeah.
So most antennas, again, that same 6 feet being off a wall, you'd like to have 6 feet below your antenna and at least 6 feet above your antenna. It depends on distance, but if you just don't put your antennas on the deck. People think, we'll just put them down low. No, they need to be 6 or 8 feet. Usually is the optimum thing without a whole lot of measurement and other things. So that will help avoid that.
And tell us about, we talk so much about multipath reflections and performance of antenna power and placement and all of these variables. You guys have a couple products that allow you to do real-time measurement and actually, so what was that program you were using at the, I guess it was an NAB in Vegas that you were measuring the noise floor with the filters? What was that called?
Our program is now called Wave Tower.
Okay.
So we make a little. I don't know if that shows.
Oh no, because your
I blocked
background.
my.
Oh, I can see
Okay.
it now. Yeah, put it in front of your face. There it is.
There we go.
Yeah.
That's my CGI background there. So we make this little handheld analyzer, and put this on your Christmas list because radio's invisible. If we can't see what's going on around us, you're going to guess from now until forever. And these are really cool because you literally can hook your antenna up to this, and you may find, once you can see it, moving your antenna 5 feet one way or the other could make 20 dB a difference in your signal. It could go up or down by 20 dB. So we make this little gizmo, and then you can export it to a computer. And what you will be doing in the future.
But that connects to a laptop to another program, right?
Yes,
or am I jumping ahead of you? Okay.
No, that's fine. So we make a program for Mac called Wave Tower.
Okay.
There are Windows programs as well. There are free programs out there. There are pay programs. Ours is like $100, depending on what you're going to do, and they have different features and benefits. But that would allow you to capture the data from the scanner, and then using a program like Wireless Workbench or IAS, maybe some of you guys do. That's going to make your life a whole lot better because that's going to tell you exactly what frequencies you can use.
And you can also real time see what your noise floor is doing.
Yes.
So if you put out a spotlight, 2 spotlights, we talked about use those in diversities, or you say, hey, I'm going to put a helical up, or I'm going to use dipoles, or whatever you're doing, you can
see what you're doing.
You can at least see it without, And then there was another thing that I saw that was really interesting to me, because early on when we did the introduction, we talked about, we land on set, Don, and it's like pictures up in an hour and a half. We might go to the Tech Scout for the first 2 episodes, but if there's block shooting and just continue to shoot, that director's tech, we don't see the location. So we arrive and we got to scan, we got to get the intent, we got to figure everything out. And but there's something, and I'm hoping this could be useful for us, called Wave Tower. Is this something that allows me to coordinate in advance at a location? And look at the RF, or am I just in left field right now? Is this?
So the answer is yes, it would. Unfortunately, because of this COVID thing, we used to make a unit, we sold out of them, and while we should have had a new unit available for Infocom or NAB, it now probably won't happen until next year. But it allows you to go ahead of time, place this at a venue, and start scanning what's going on even without being there. So you can go home, you can see it from your phone or your computer and see what's there. So you could calculate all this stuff. If you were getting on a tour bus, you could FedEx it to the next place, have them plug it in, and you could be looking at it on the reg there.
So it's a hardware device.
It's a hardware device. It's basically just that scanner that has a network connection that allows it to report everything to a cloud, and then you're just looking at the cloud.
So we could use if we are on a Tech Scout, we can use the RF Explorer, we can scan and then come back to the coordination software of whatever we're using, put in that data, and go.
Yeah, our program actually has a sort of a junior version of a coordination program in it. If you're using a dozen or 16 microphones, it'll work. If you have to use 50 microphones, you'll need IAS. But, so yeah, with a laptop and that little black thing I was showing you, you could push a few buttons, in about 2 minutes you could find out what frequencies you should be running at. For any given location.
That's great. Well, Don, I'm going to give some time for our participants here to ask some of the questions that they have, and this has been so enlightening. I think that it's just this really helps us. I mean, not only has it been beneficial for you to give of your time today and share your wealth of experience as a senior RF applications engineer and some of the challenges that we deal with on film sets, but also I love that we all have now this homework to go take the webinar series, do all this stuff, because I'm a big proponent of, maximizing the investment that I've already made, so I mean, I want to make the wireless that I have work as long and as well as it can. And, there's a lot of pushes like, oh, we got to go all digital, or we got to do this, or we got to have this. And yes, a lot of that might have some merit, but also, are we getting 100% out of our systems? And all of this information that you've given us today has just been extremely valuable. So thank you for that. So let's go over here to some questions. And I'm just going to scroll here out of respect for Don's time. Hello, everyone. Thank you for saying hello. We got a lot of hellos. And let's see here. Scrolling down. So here's a Kevin Strand. Thanks for being here, buddy. He was saying that he's a Part 74 license holder as well. There was a big push through our unions, Don, and just in general to make sure that production sound mixers were getting Part 74 licenses and doing so primarily so the FCC sees the wireless microphone users out there, because it seems like without that, we're invisible. Plus, we have access to 941, right? With Part 74 and also...
Actually, no, you don't. There will be a new license that works at 941.
I'm holding on to my document that says I got 10 years.
Yeah,
941, and I'm not giving it up.
Yeah,
but elaborate. I'm just joking. Elaborate on what you said. Yeah, you said there's a new license.
As far as I understand, there will be a new license. Yeah, that works up there of that X-band.
Oh, wow.
I'm not an expert, and frankly, dealing with the FCC is a nightmare.
Yeah.
So stay tuned for that. It doesn't exist yet, but actually, Henry Cohen told me that. Probably you guys have worked with him a bit, some of you. And he's very tied into Congress and all that stuff, and the FCC. My understanding is there will be a new something you got to do.
Yeah.
Do it. I assume if you guys are if you're working in movie and television production, it's easy to get a Part 74.
That's right.
It's very difficult for anybody else to get one. So you guys are lucky there. They may hit you up for a few more bucks to get an add-on to your license, but I understand there will be something. I don't think there's anything. I don't think there's anything specifically that runs in that band. It has to have been refocused.
Yeah.
So it has to be specifically locked into those frequencies and can't tune any place else. And I think they shifted that a little bit. So you'll have to double check me on that one.
Yeah,
doesn't matter. You'll get there.
Yeah, absolutely. And I'm putting some of these comments and questions up on the screen here, Don. Matt Thompson says, hey, from LA, happy to hear from the Atlanta sound community. Matt, thank you for being here and saying hello. And always great to see everyone here. Here's an interesting comment from Ken Goodwin. He says, New York noise floor is minus 78 dBm outside. What do you think about that, Don?
And go up in a building and it's worse. Go up to the 10th story or the 50th story and it goes up 15 dB.
Yeah.
We didn't cover that. Noise gets worse as you go up in the air. That's minus 78 is doable with a fair amount of work. Where you'd really like to be is down around minus 90, minus 85, but minus 80, minus 75 is doable. You won't get as many channels, and so if you have to do 150 microphones in minus 78, you need to call Jason Glass that did that the link budget thing.
Yeah.
That is a very difficult job. It's really hard in the city.
Yeah, and Don, and speaking of dBm or dB is a logarithmic scale. So when we're thinking about 20 dB of space, does that change as the noise floor goes up?
No, you still need that
because it's not linear, is it?
No, but the voltages change non-linearly, but the distance, if you're 50%, whether you're 50% of 50 things or 50% of 5,000 things, you're still 50%.
Okay.
So that's why we use dB, because
I see.
that part of it's constant.
Okay. Thank you, Ken, for the. So Kevin has another comment. He says, I beat up my coax so bad on every show. I relate to you, Kevin. I mean, Don, I called one of my mixer friends, a week before, and I said, listen, I'm gonna buy all new coax cable. He's like, what? I was like, yes. I don't know. I mean, I'm paying. I don't even. I use the LMR 240, Don, but it's real Gumby like, which is kind of scary. When you talk about the sphere, I guess the core is thicker, and if it gets bent, it stays. Is what I mean by Gumby.
Yeah.
And I wonder if that's not such a good thing.
Well, if you really want to know, you'd have to look up for each wire. LMR 240 is a very good cable.
Yeah.
But it has a spec for bend radius.
Oh, okay.
So it'll tell you 6-inch, 12-inch. Generally, I just rule of thumb without knowing anything.
Yeah.
I would go. It needs to be somewhere. I would like it to be 20 times the diameter of the cable, right?
Okay.
So if the cable's 1/4 of an inch,
mm-hmm.
then you need to have at least a 5-inch bend radius in it.
That's great. So that's a common spec on a professional cable.
Yeah, there's an actual number. Some cables are a little better at others than that. Some will actually go down to like 10 times. I still wouldn't do it.
You guys said don't use the RG58 anymore, or there was a cable.
Yeah, RG58. That's what everybody used to use. Mm-hmm. If you've got RG58, do yourself a favor, throw it away, and get RG8X if you want a small cable like that.
Yeah.
LMR 195.
Okay.
If you're into LMRs, most of the rental stuff is LMR that people use.
Oh,
LMR 240, LMR 400. Those are all good cables. LMR 400, it's big around as a dime. But if you've got to go a couple hundred feet,
mm-hmm.
and then if you've got to go, 500 feet or 5,000 feet, I got something for that. Call me. I can hook you up. But you got to go to fiber. It's expensive, but that's what you got to do.
Speaking of cable, another interesting thing that I saw is you said don't make your own cables. Why is that?
Yeah. So that we know they get made right. We use very good cable. We get a variant of RG8X that's made for us. Mm-hmm. It's very low loss. We have very expensive machinery that makes it perfectly, mm-hmm. and we individually test each and every cable that comes off the line to make sure that it's working the way it's supposed to, because brand new cables always look good. I mean, I have to laugh every time what cables? Oh, they're brand new ones. Well, that doesn't mean they work. That means they're new. And we have to prove the cables out. So we do that, and it adds a little money to it. They're certified. Every cable is certified.
Like a lot of us will make our own audio cables and stuff like that, but it's good to learn that coax is a whole different world.
Yeah, I wouldn't make my own coax cables.
Yeah. So don't go to YouTube and figure out how to do that and think, because you could be experiencing some problems in your cable and not even know it.
Yeah.
On your system. That's a great. So all right. So scrolling right along here. Oh, here's a comment from Fierce Sound. I have the RF Explorer. I'd like to know who to test my cables with if I can. I second that too, Don. I wonder if any of our dealers have the ability to test cables, because to me, if I had to replace all my coax cable, I mean, on my carts I keep 2 100-foot lines. I got a 25-foot line and maybe some spares. I mean, in the LMR 240, I have 100-foot runs and its diversity pair. I mean, that cost me almost $400 per 100-foot. You do the math, it's $1,500 worth of cable.
Yep.
So the prospect of replacing that for each show is a little bit daunting. But
do you use leftover batteries?
Yeah.
So that's what you're doing. You're using leftover batteries with your cable. Like I said, if I told you your cables were 80%, I can't tell you whether 80% doable or not. It
Yeah.
is in some cases. In some cases, you might be able to get by with 25% cable. In some places, you might not be able to get by with 95% cable.
Yeah.
So it's that kind of thing, unfortunately.
Yeah.
And frankly, I doubt any retailer has the ability to do this. Possibly, if you deal with somebody that has an RF repair shop, that requires licensing, and they go through a whole bunch of stuff they got to do. It's possible.
Yeah, and if there are, we have a lot of professionals on this channel, Don. If there are any dealers here, please put comments below on the video if you have the ability to test coax cables properly with the type of equipment Don's talking about. Can we send them to you guys? Can they be shipped to you for testing?
We don't have. It would be shop time. It would be something. You're paying.
Well, there would be a cost.
Bench time's $100 an hour for everybody, right?
Yeah.
It takes a while.
Okay.
We don't do that. Actually, right now with the COVID thing, we definitely don't do that because we're working on a somewhat reduced staff. But you know what? I never thought about that. I'll reach out to some people that I think might be able to do it, and if I can generate a list,
I would love to have mine tested before I chuck them all.
I'll look into that. I never thought about that.
Yeah. So here's a comment question from DCPI Film Services. He says, did anyone else just go through all their transmitters and set them to the lowest output? I did on my last job, so thanks for the comment, DCPI.
Yeah. So do understand the lowest that works. The lowest that works might be full power, but
that's true.
If it works, if you can put it on half power and you're still, like I said, so if you've got, let's say you've got 5 LEDs on the ladder, you're not looking to fill the top one. You're looking to fill the second to the top one.
Okay.
Because as somebody moves around, they're going to get close and they're going to hit that top one. So if you're already at 100 and somebody gets really close to your antenna, you're going to have a bad day. So you don't want to be at 100. You want to be at like 80%.
What physically happens when we overload an RF system?
You distort the hell out of the first RF amp.
Okay. Which usually results in a dropout, audible distortion. What are the symptoms?
It would be definitely dropout with a digital system. With an analog system, it'll be horribly crappy noise until it drops out.
Yeah.
Which could happen quickly. But I mean, it's like plugging a line level signal into a microphone input. That's what's going to happen.
And we're all familiar with the lovely sound of 2 transmitters screaming at the same frequency. It's kind of like your ears getting scratched by a saw on a rock top or something. It's pretty horrible. Okay, so all right, moving right along here. A lot of the users saying, "Hey, I've kept my transmitters around 50 milliwatt for that reason." We already answered the question on can you lower the noise floor on any antenna using a filter gain. Here Kevin says he has a diversity fin here. User, love it. And I also have one of those diversity fins, and we talked about that, Don. It's a convenient, compact solution I like to typically use for close range microphones. I find is, usually I would probably buy a couple more of your LPDAs or helicals for longer range film set stuff.
Well, realize it is an LPDA.
It is. With a dipole cross polarized, right?
Right. So what happens? So kind of how that works. It does help to minimize multipath because diversity isn't required. Again, if we stand out in a cornfield in Indiana, I have no reflections and I have no interference. I don't need to worry about it going off the air. But when other things are encroaching on me, then I have to be able to switch over to a backup channel.
Okay.
The way our system works, and in fact, and this confuses people, there are 2 different strengths of antenna. So the little dipole is an omnidirectional plan B. It switches there when the other one doesn't work, but the LPDA stays on almost all the time.
Okay.
And it has the same gain as any other paddle that you have. They all have about 5 or 6 dB.
But it also depends on the diversity mode that you're using on the receiver side as well. Because some use ratio diversity, switch diversity, different types of... Is that correct? Yeah.
A lot of you guys are using Electro. Electro has a thing that sometimes allows it to combine two...
that's ratio diversity.
Yeah, okay. Yeah, but what they don't tell you is that also has the ability to take it away. So there's a plus side and a minus side to that. So, you've got a middle ground, and sometimes it's a plus side, but it could have a minus side too.
Yeah.
So it's, again, it all depends where you are. Most of the time that's a benefit, but be aware that can be different. So you went over this just quickly. Antennas do not have to match. Cable links do not have to match. What has to be, it has to be the right tool for the job.
Okay.
So a strong antenna with a really long cable and a weak antenna with a really short cable could be exactly what you need, or it could be exactly wrong. But it's about being right or wrong, not about the fact that they're balanced. They do not have to be balanced.
Okay.
I mean, just realize you'll have a stronger signal in one and a weaker in the other. And that might be exactly the right thing. That's what we do on purpose with that diversity fin. And it helps mitigate multipath. So.
Yeah. And Don, we're going to keep going through the questions here, and I am literally changing.
Wow, look at those legs. Oh, you were
changing. Oh, do you like that? as I'm changing the battery out on my.
Yeah, did you see? There was a newscaster somewhere. All these guys are working from home.
Yeah.
There was a guy. He had the jacket and the shirt and the tie. He wasn't wearing any pants, and he didn't realize. He pulled back just enough to see that there were his boxer shorts.
Oh, that's great.
When you're on national TV news, probably not. Well, I don't know. Get a little levity always helps, I guess.
So here's a question from a user. Great talk. Please talk about frequency band at some point. I'm trying to invest on my first wireless system, or maybe it's irrelevant with just one or two systems. He's a Sony UWP D21 user. Sorry if I am far off topic. Any recommendations as far as where to buy for a first-time buyer in a frequency range and what we're experiencing right now, Don?
Well, nobody can tell you with 100% certainty the answer to that question. But I would say my best guess right now, would be right above 512.
Okay.
It's fine if you go lower than that, but I would like to be. So I would say between 550 and 500 would be a good bet.
Yeah.
If you don't need to use very many channels. If you need to use a lot of channels, then you'll have to buy multiple stuff.
That's great. That's great. Thank you for the question, Oki. Here's a comment from Ken Goodwin, and I think it's a good one. He says, get both of your antennas off the cart. We have a lot of RF coming off of our sound carts from equipment. We have transmitter antennas, some of us, for context and VHF band and 216, Don. And he's recommending or saying, get the antennas, I'm assuming the diversity receiver pair for talent off of the cart. Should we be isolating antennas as far apart as we can, or what's the rule of thumb in your opinion, Don?
If you're both transmitting and receiving, then yes, because you have one antenna that's pitching and one antenna that's catching. You don't want those close together.
Yeah.
The bandpass filters will help that a lot. So if your IFBs are at one end of the band and your mics are at the other end of the band, you put the bandpass filter and your IFBs become invisible to your microphones. Now it won't work the other way around because the bandpass filters go on receivers, not transmitters.
Yeah.
But you want to separate those things as much as you can. And there's a good blog post for that with a lot of graphs and pictures that'll make that a lot more clear.
Yeah, thanks for the comment, Ken. And then Daniel Gribbs got a question. Says, in regards to RF reflection, is there some way to help reduce the reflection from metal surfaces if there are no way around it? And that's a good question. Like, is the access of the receiver antenna, like, can you if you're pointed right into that garage that you're talking about, Don, if you go, say, 90 degrees more on a side pattern and it's less in the pickup pattern of the antenna, does that help with multipath if the talent's walking next to that garage?
I'm trying to visualize that for a minute. The answer is I don't think so.
Okay.
Metal's a problem, and you're going to get multipath. I mean, the only way to do that would be if you were to put the antenna up backwards against the metal door and shoot out away from it. But that's probably going to be in your shot, so that's probably not going to happen.
Or hopefully your diversity system is going to help negate that as well. Or
so that's tricky. Again, because you're flipping polarity every time you bounce off a piece of metal, it's like a pool balls going across the table. You're plus, you're minus, you're plus, you're minus, you're plus, you're minus. It doesn't matter until you get enough reflections. That's the problem. Is that your receiver will handle a number of them based on other things, based on how good your receivers are. Yeah. And there's a point you just overload the system.
Yeah, I remember doing a scene in a recent show where they were talking through a chain link fence.
There's a good point. Chain link, to pass a radio wave. So with what we're dealing with, 480 to 608, a radio wave is about 2 feet long.
Mm-hmm.
If your chain link fence was 2 foot squares, it would pass RF through it. But chain link is like 4 inches. It might as well be solid steel.
Yeah, it was a rough day.
Yeah. I get that all the time with people that want to do baseball, right? It will not go through chain link fences. Yeah. It might as well be solid steel.
Luckily my boom op was really sharp on that show, and he said, Michael, this chain link is going to be a bitch. Get ready. Yeah.
Also, think about window frames.
Okay.
If the window is 2 foot by 2 foot, it'll go through it. If it's smaller than that, it won't.
Okay.
Okay.
So, thank you, Daniel. Michael says, Daniel, any way you can help either on the transmitter or receiver side, transmitter improve antenna, space from metal. Yeah. So Michael's just saying, hey, get the antenna away from the metal. It's just one of these. You had also spoke a lot about, Don, on your webinar series about decreasing the space of air in between the transmitter and the receiver rather than increasing power.
So if you've got a belt pack on somebody and they've got it under their costume, under their clothes, and the antenna is touching their skin, the difference in that antenna touching their skin or being a half inch away from their skin, like you've got it on a belt on the outside of your pants, you will lose half of your signal because that antenna is touching their skin. That's why we went over it. If you have the kind that have like a little wire hanging down, if you put a little piece of soda straw on that, at least, believe it or not, being half of a soda straw width off your skin will make a very definite difference.
That's great.
So if you can do that, I know it's tough with especially women and costumes and what can stick out and what can't. But I know you fight that stuff all the time. You can only do what you can do, and you get the last choice, right? The director always wins what they want. But
yeah. And I'm just scrolling here through the questions. Thank you guys for the questions and getting through a lot of excellent comments. Here's a question from Michael. Don, would it be beneficial for reducing IMD? I'm assuming it means intermodulation. I don't know why I can't say that word. To increase your channel spacing on your primary channels first. So let me read it one more time because I paused. I apologize. Don, would it be beneficial for reducing IMD to increase your channel spacing on your primary channels first?
Sometimes. So it gets really complicated as you continue to add units, right? So the number, that's why they never let you use cell phones in an airplane, by the way, right? Imagine 200 people with cell phones scrolling through all the frequencies that cell phones do, they are literally making billions of phantom radio stations. Fortunately, they're far enough away from navigation that we never brought down any 747s, and it turns out not to be a problem. But the number goes up quickly. So when you have 8 wireless microphones, you have 40,000 intermod frequencies that, depending on where you're standing. Now, see, if I'm this close, I get them. If I back apart, whoop, there we go. If I'm 10 feet away, they go away. But they're potential. So as people are moving in and out of that space, and 3 guys get close to 1 guy, or 2 guys do, or 5 guys do, it's all different. You're never going to get all 40,000 of those at the same time. But those are the frequencies where it's going to change. Okay. So it's the multiples. It's not the spacing, because it's going to put them where it's going to put them. It's not the spacing until they get really farther apart than you could do with wireless mics.
Okay.
So
that's a great question too, Michael.
Yeah.
About spacing.
That's one thing. I used to get people all the time. They go, "Well, let's put it 500, 501, 502, 503, or 510, 520, 540." That seems to work, but it doesn't, because the multiples will get you. So it's exactly the spacing that really makes it bite you or not. It's unfortunately not that simple.
Yeah. And here's a comment from Scott Beatty. Scott, thanks for being here. Good to see you. He says, Don, thanks for all of your killer products and advice. It has aided me tremendously over the years.
Good.
Scott does a lot of very complex wireless type systems for the shows that he works on. So he's very familiar with pretty complex high channel count setups. Thanks, Scott, for being here. Here's another question from DCPI Film Services. As someone who mostly works from a bag, what would be some of the best practices to follow, especially if I have a camera hop transmitter in my bag?
Well, you're really limited. I mean, because you have a physical distance that you have to do everything in. Mm-hmm. Definitely 100% shielded coax for everything that's in that bag. That's cheap and dirty. That would be the first thing I would do.
Combining RF. So if you don't want a bunch of diversity pairs and independent transmitters close to each other,
okay,
like an RF multi or something from PSC,
I'm sorry, I thought we were past that. Yeah, absolutely. Yeah. So understand when you have two receivers, with their antennas like this, they steal power from each other, and also what people don't remember, I told you that it backs up. What people don't realize is when you shove power into that antenna, it bounces back out, it transmits. So in a good day, 90% of the power that hits that antenna goes into your receiver, 10% is transmitted back out. So if I've got two things that are right close to each other, this one's transmitting into this thing that's right next door. So in theory, you should never have your pair, it won't show on the screen, they need to be at least 3 feet apart. Okay. That gets to be pretty tough by the time you got 8 of them. You got 30 feet you got to have between the left side and the right side. So, but again, with the bag, you can only go so far. So you're gonna suffer what happens because of that.
Yeah,
you really need to have a distro and one pair of antennas.
And there's some excellent products out there, PSC with their 6-pack, 12-pack, where they're basically taking these multiple antennas or their RF multi-SNA system that are compatible with the Aton recorders, the X3, the Mini. Also Zaxcom with their Nova has that. So we're seeing a lot more technology, sound devices with their SL2, SL6. And, so fortunately, that problem is actually being solved more with some of the newer technology that we're seeing. And,
they're starting to build it in. Yeah.
Yeah. Yeah.
They should have started 20 years ago, but now they're getting the message.
Yeah, exactly. So, thanks for the question. And Here's another question from Alari Civil. Have you any tips for using transmitters close to receiver antenna? So, like, if he's in a bag, again, like, should we be thinking about something with power, Don? If they have to be in close proximity, what can we do? Can we shield them from each other, with material, or what are your thoughts?
Well,
you said coax cable already, yeah.
Yeah, if you read the fine print somewhere in your owner's manual, it will tell you never should have your transmitter closer than 6 or 10 feet to an antenna.
Mm-hmm.
And if that's unavoidable, then it is. You can pad the antenna.
Of the transmitter or the receiver?
The receiver.
Okay.
It would be difficult to do on the transmitter side. So,
okay.
And it would be better on the receiver side. You can get, frankly, you guys, you should have a pile of little barrel pads, right?
Yep.
They're little and round. They got a BNC connector, an SMA connector on either side. They're $6 a piece on Amazon. You should have 6, 10, 15, a pair of each of those in your bag. Cost you $25.
And these are to pad the receiver cables from being overloaded, correct?
Yes.
From nearby transmitters that aren't sending RF signal that we want. But
they'll block everything.
They'll block everything.
If your signal is so strong that you're wiping out your antenna, you're wiping out your receiver, actually.
Which is the reason for the pad. Okay.
Yeah. So just be careful when you order those that you get 50 ohm pads. They look exactly the same. 75s are for TV antenna work. So if you want to do your cable TV at home, get 75s. But your wireless microphones all work with 50s.
It's amazing, Don, that you just answered the next question with your last comment. He says,
clairvoyant, right?
He says, yeah, Don can't actually see. I'm reading him the questions, guys, because he's piped in through a Skype. So so the question was, hello, great info. What about 75 ohms cable?
Yeah, so there's a lot of misinformation about that. So in a pinch, 75 will work. 75 is lower loss. This has all to do with quality of signal versus power loss in the cable. And where they worked it out that 30 ohms was the best quality, and that 75 ohms was the lowest loss. And so what the wireless microphone people did was split the difference and give you 50. So it's a trade-off. But everything wireless, everything I've ever seen in your wireless mic catalogs is going to be 50 ohms. So best to be 50 because, we talked about filters that are built in. They depend on that impedance to be 50. If it's not, the filter will shift frequency. Yeah. So in a pinch, you could use 75. It will pass the signal, but it will. So you'll have less loss, but you'll have mismatch. Just use 50.
Use 50. 75 for video, as Kevin says. You says 75 ohm is for video. Absolutely. So here's guys, out of respect for Don's time, I'm going to do my best to get through the rest of these. No promises, but we'll do the best. So Gil's question, Malay, I try to pronounce that correctly. It says, hello from up here in Canada. In A and B band, we have trouble with walkie blasts from ADs. I'm curious if there's anything we can do to protect ourselves in terms of fin placement.
Bandpass filters. So that will block. So we make bandpass. Let me talk about bandpass filters for a second. We make bandpass filters that basically are the high half of the band and the low half of the band. Now, if you're using electro stuff, I guess I should back up one. The wider the filter is, the easier it is to work with, the more versatile it is to work with, but the less effective it is. Electro makes block filters per block. So if you buy a filter for block 21, you buy a filter for block 20, you buy a filter for block 19.
Yep.
We make a filter that would encompass about 8 electro blocks, I guess. So you can get one set of filters that you can cover all those. So as you work, if you work all over the world or you work all over the country, then your choice is going to be different to I only work in downtown Atlanta. I know what's there and it's not going to change. So in that case, the electro blocks might be better they'll work better, but they only work where they work. So you have to buy a bunch of them.
That's right.
And what you're really trying to block out is walkies on the low end, because some guy can walk up, just out of the clear blue. You've been good all day, and he walks up, and you're off. And T-Mobile, T-Mobile's everywhere now. So, and it's going to get worse. It's going to get many orders of magnitude more potent than it is today.
Especially in that area, Don, and I really appreciate you sharing with us how it affects the noise floor. Because I think so many of us thinking, well, I just have to get my wireless out of that band and then I'm good. And it's all about fitting in the spaces.
Yeah.
But it's much more than that. And I'm going to paraphrase some of these questions, guys, so we can get through all of them very quickly. Where should the bandpass filters be placed, Don, in the signal chain?
So they're on the receiver line. They're probably best, although it won't make a whole lot of difference, but probably best as far away from the antenna and as close to the distro or the receiver as you can get them. So typically, antenna, long piece of cable, bandpass filter into the distro, and then into your system.
Okay.
Would be, they'll work if you go out of the antenna straight into the bandpass, but if you have it farther down the chain, you also will take some noise should the cable contribute any noise.
Excellent.
So you want to have it as close to the receivers as possible.
That's great. And Jeff,
not a big difference, just a little.
Great. Thank you, Don. And Jeff Cools asked, what about putting LPDAs one horizontal, one vertical for polarization? Would you recommend that?
Yes.
Any drawbacks?
Yeah, somebody will move it. It won't stay that way.
Yeah.
So, if that's simply in our antenna, it's locked down. That's what we did. They're orthogonal antennas, right? One's 90 this way and one's this way, and they're locked. You can't move them.
Okay.
There's a question that comes up. Well, wait a minute. I thought you had to split antennas. You either need to split them or they need to be exactly on top of each other, right? Phase delay, timing delay. If they're on top of each other, they're not out of time. If they're a little bit, they're out of time. When they get really far apart, they're so far out of time it doesn't matter anymore. So,
yeah. Thank you.
Same way with microphones. Same thing.
Yeah, and so just kind of scrolling through here, guys. Talking about full wavelength. Right. Okay, great. So thank you, Jeff, for the question. Thank you, everyone, for the questions. And looks like we have a question from Scott I'm going to put up here. It says, can you discuss using the Delta scanning tools for film, diagnosing camera or LED RF emissions, and is this possible with RF Venue Vantage software?
Yes. It'll pop right up.
That's great. And thank you, Scott, for the questions. And here's a question from Michael. Don, when measuring if RF will pass through a fence, are you talking about a full wavelength or half wavelength or quarter, which will not pass through? What's the
full? Imagine your radio wave is a stick.
Mm-hmm.
So now you'll get bounce and stuff, but just your primary wave, if it's coming horizontally or vertically, is a stick 2 feet wide. You got to be able to push it through that opening. You can't turn it sideways. It doesn't do that. It just emanates, coming as a straight force at you.
Yeah.
So
thank you.
Just imagine it's solid. No, you don't get a quarter of a wave through. That doesn't work.
Thank you for the question, Michael. And it looks like we have one last question, guys, and we're going to wrap up here. This is from Greg Palmer. Hey, Greg, great to hear from you. What are the frequency considerations working out of a bag with receiver versus transmitter for a camera hop? So let me read it one more time. What are the frequency considerations working out of a bag with a receiver and transmitter? I think what he's saying, Don, is about spacing for frequency. So if you do have a transmitter and receiver working in closer proximity than what you would like, should we be thinking about spacing them frequency-wise? Does that help with the performance?
Oh yeah, but you've got to get them really far apart.
Okay.
You won't be able to get them that far apart.
Yeah.
If they're both in UHF TV band. Now, if one's transmitting at 2.4 or 5 gigahertz or VHF 172 megahertz and one's at 500, yeah, that's fine. But if one's at 470 and one's at 590, that's not far enough apart. Okay. I mean, it helps, but just minuscule.
Yeah.
You're just stuck. So
well, Don, I want to say thank you so much for all of your time, and I really appreciate you going the length that you did. I know our target length was an hour to start, and we went much longer. So I appreciate your time, and everyone's just saying thank you so much here on the stream. Thank you, everyone, for tuning in and to this. I know I've learned a lot, and I appreciate everyone being here and asking such great questions, because it was very helpful. And I think with that, we're going to sign off, and
okay,
that's it, right?
All right.
All right. Till the next one, guys. Thanks again.
Thanks,
we'll see
guys.
you soon.